Hello everyone and welcome to today's webinar titled Understanding 5G, What We've Seen from Lab to Field, brought to you by VIAVI Solutions. This webinar will explore best 5G practices and learnings from early commercial 5G launches and the tools needed to validate performance, test services and deliver network optimization and maintenance. This webinar is part of the Command and Network Spring/Summer webinar series. To register for future webinars or watch recordings of previous webinars, we will provide details at the end of the webinar. So just to say that this webinar is approximately 1 hour in length. It is being recorded and you could submit your subject matter questions for the presenter via the Q&A panel. Questions will be answered at the end of the presentation as part of the Q&A segment of the webinar. If time is limited, then the presenter will respond directly to you with the answer to your question. I'd like to now pass over to Ahmed Annan, Director of Sales for Middle East Africa at VIAVI Solutions, to start this webinar. Over to you, Ahmed.
Thank you, Carol. Hello, everyone. Thank you for being again in one of our webinars. And today will be a really interesting day for you guys, where we are having our experts from the early 5G commercial launches, and we really talk about more details into that. So here is a quick view on the agenda. We'll talk first about some quick intro for VIAVI Solutions, and then we'll go more into testing 5G network services in the lab, and then the changes that happened in the network due to 5G implementation, and what are the recommendations for 5G field testing procedures. So moving first, we'll talk about the quick introduction for VIAVI Solutions. As a company, as VIAVI Solutions, we're a company that's really made of long history. And some facts and figures that should help you understand the size and scope of the company. Some things, that you can take away from this slide are that VIAVI is a global company with rich history in technology innovation. We're really solid financially with the numbers shown in front of you for the last fiscal year. With really solid revenues, and with like all the successful companies, the key important thing for us is to invest into people. Either our own employees, which is more than 4,100 employees, or also our valued partners, which is almost 350 partners globally, like Continue, who are helping us with this seminar. They are our master distributor for Middle East and Africa. Being global present company in more than 50 locations directly as ourselves allows us to participate in a wide range of country and region specific forums, which is really enabling us to be part of more than 2,000 patents, technology patents. And how that will help us? It all help into one direction, which is supporting our global customers who owns more than 1.6 million instruments globally in the best way possible. VIAVI is headquartered in San Jose, California in US. Okay, so when I mentioned a rich history in technology innovation, how far that goes. Moving to the next slide, you will find that VIAVI as a company has been, can be tracked back nearly more than 100 years. We've built our company up from our roots as pioneers in the copper testing, and now we're helping to build, monitor, and optimize the world's most complex mobile and enterprise networks. It's true that over these years, we continually introduce test solutions born from our own engineering teams. But in this slide, you will show that our leadership in test and measurement is also due to a long history of strategic acquisitions for a main task, which is complement the portfolio to make sure that we're offering you a full portfolio here. Some of the acquisitions, like what happened in 1998, acquiring WaveTech, in 2000, acquiring Nocturna and become the JDSU name, and then acquiring the NSD division from Agilent, which really enriched the portfolio big time, with other multiple acquisitions. And the most recent one, which is really helping to enrich the 5G portfolio for VIAVI, is the Cobham wireless acquisition and the 3Z for the RF vision or the RF antenna alignment. Each of these acquisitions brings not just new products, but also new expertise and skills into our collective knowledge base. And we're committed to maintain and grow our position in the test and measurement for the sake of supporting you as our customers and our partners. Moving to the next slide. Maintaining and growing our position here is happening via, being proactively addressing the key technology trends in the telecom industry and address every and each stage of these industry trends. As you will hear later on today and also in the other webinars that will be proposed at the end of the slides, VIAVI is one of the top test and measurement vendors addressing either 5G from the lab to the field, providing the validation, the verification, and the visibility, and also all the other supported parts of the network that's really supporting the new evolution for the 5G. For example, with the 5G technology appearing, the fiber network's value increases more and more. VIAVI has more than 45 years of experience in enabling the customers to test the fiber networks, and these 45 years is really allowing us to be the best advisor for how to design, deploy, and maintain these valuable assets in your network, which is your fiber network. Beyond the design and manufacturing of test and measurement solutions, not only this is our task, we're very much focusing on developing the testing automation. And this will be showed in one of the slides at the end of the presentation today, where the field testers can become part of your workforce management systems in a fully automated way, eliminating the need to be having the manual processing, dependence or the dependency on the technician's experience and all these things. We're really helping you to have reliable and automated sources of data into your network or into your systems. Okay, so if we move to the next slide, how do we utilize all what we have done in these new technology trends? The answer is when we improve our visibility and we improve the visibility. We provide you the visibility. Either the visibility when it comes to different networks and technologies for the service providers, like the wirelines, like wireless, data centers, cloud providers, the NEMs, or the government and defense, or even a field prime contractor. So different types of networks. Not only that, different parts of the network as well, like the access network, the transport or the aggregation network, the backbone network, with different flavors of solutions from VIAVI, matching the nature of your networks, either physically or virtually, for the types of testing, assurance, and monitoring that's required. Not only that, also the different life cycle of the network. Either it's researching, planning, designing, building the network, testing it in the field, activating it and commission it, monitor and manage afterwards for the troubleshooting, or even for the plans of evolving the network. There are different solutions in VIAVI that can help you to do that. And I'm sure if you will go through the library that we have for the webinars, you will find different data, either the recorded sessions that we had before or the planned ones during the summer, which really addresses every and each part of what I've mentioned above. Okay, so moving to the next slide, we're just showing part of our legacy. No, next slide, please. Now, thank you. This is what really VIAVI is made of. We're mainly working to enhance the experience of those people. Those are our partners, our true partners. The service providers we've worked with, these are global lists. Of course, there are regional lists that can be adapted to everyone's region. So please feel free to reach out to your VIAVI representative, either VIAVI person or channel partner in your region, and he can provide to you this list of people that we've worked with for the past, 100 years, as I said. So with that, I would conclude the introduction part. I will be here as well, trying as much as possible to support you guys during the presentation, the questions and the polls, and feel free to place any questions you would have into the questions window. Either the questions will be addressed during the presentation if possible, otherwise it will be addressed at the end in the Q&A section. And I will hand over to you now, Janice. Thank you.
Thank you, Ahmed, and thank you everybody for attending this webinar today. The next 3 sections basically will cover testing 5G network services in the lab, the experiences that we have got so far with a number of our customers that they are doing validation of new 5G services in their labs. They also will review 5G network changes in the areas like fiber, transport, and radio, and how those are impacting the way that we assess now the quality, the performance of these new networks. And the final section will review the recommendations that we have for 5G field testing procedures based on our experience 2 years now working with customers since the very early inception of 5G technology in the market. So moving with the lab section, despite the tremendous user growth that we see in cellular networks these days, the reality is that our customers, mobile service providers, are looking for verticals to improve their return of investment. And 5G technology offers them the potential ability to achieve that. However, some of these verticals are bringing major challenges in terms of securing network quality and reliability, right? For example, mission critical applications will demand a network which can fail, which means ensuring network quality will be at the core of the network deployment and the management functions. So whether this is the fiber interface, which will do all the heavy lifting for these 5G networks, or the air interface, which manage all the critical applications on a more agile network core, all of them must be continuously monitored and optimized. At VIAVI Solutions, we believe the quality of the networks will depend on the rigor of testing and measurement during the complete life cycle of that network. In 5G today, particularly, this may include a continued lab-to-field validation, because it is expected 5G will go, in fact, through a continued technology evolution in the upcoming years, something that we already see today with the introduction of features like dynamic spectrum sharing or standalone mode, for example, among other novelties. So many mobile service providers today carry a number of network validations in a lab environment of their own to ensure, for example, their cellular subscribers experience a high-quality service, and if we may say so, for the lowest possible price, right? So that's also always a consideration. So for mobile operators, it is also essential to ensure that all network components and their interfaces are delivering as per design to reduce CapEx and OpEx. One additional challenge here for these network labs in 5G is the upcoming need to validate different classes of services, like the very famous enhanced mobile broadband, right? Of the massive machine type of communications, or the ultra reliable low latency communications that everybody's been talking about at the beginning of the 5G cycle. And all these will come with different service level agreements, different latency conditions, disaggregated nodal functions, and the list goes on, right? So a traditional, well-proof approach in network validation labs has been to test different network functionalities by loading the network to test it under stress. And with today's solutions, with today's solution platforms, this can be done from different angles, even simultaneously. On one hand, it is possible to conduct traffic emulation from user equipment to the RAN that simulates, for example, many mobile phones, in the thousands, in fact, with real data flows across single and multiple base stations. From a different angle, from the other angle, it is also possible to conduct a RAN to core traffic loading test that loads either the core to test the RAN, or the RAN to test the core, either way, right? So these are different methodologies available today for network services validation in a service provider lab. Here are some examples for traffic emulation testing, some of the things that we can validate in a mobile operator lab for network optimization, assurance, or capacity testing. In general, there are many different types of test scenarios that can be supported in a network validation lab when the RAN or the core are the device under test. So these include, for example, layer and component tests, or systems or applications test, end-to-end testing, including new requirements, for example, for network slicing and mobile edge computer, to name a few. In terms of performance optimization or capacity testing, we can check items like what are the maximum data rates, latencies, quality of service targets here that are where are the bottlenecks, for example, in my network, right? And when it comes to capacity, if the network is stressed with thousands of UEs with real data applications, is it working as expected? Of course, a lot of this validation testing has the objective to ensure an efficient use in the field of a very expensive frequency spectrum. So the continued user demand for optimized services and capacity is ultimately the main driver for all these testing requirements. When it comes to run-to-core emulation testing, there are many interesting things we can do as well. For example, we can provide real data application emulation for voice, video, and data, or emulate 4G and 5G signaling traffic from the base stations into the core and the other way around, or even stress load across the new F1 interface in 5G, emulating the distributed units to test the decentralized units in 5G. Examples of this type of testing are related to the introduction of new types of data applications, or also the classic regression tests, right? So for example, in terms of application emulation, imagine we are introducing a new IoT machine type of data application, and we want to know how is this working end-to-end in the network when real data applications are added, for example, additional video, voice services. What are the quality of experience measurements there, and how does it reflect on the overall quality of experience on the user side? Regression tests, on the other hand, they make sure that the network is stable and the results are repeatable with control automation testing, and also that we can shorten time to market of new releases and features before they go into production to the commercial network. Right? One particular test case that we see in growing demand these days with our customers when it comes to their 5G network labs is the one related to validation of functionalities associated to the Open RAN initiative. The purpose of this presentation is not to elaborate in detail what Open RAN does. In fact, we do have another upcoming webinar on that subject in very few days. So maybe you want to check on that as well if you're interested in more details on Open RAN. But the benefits of Open RAN are probably clear to many folks in the audience today, and include a reduction of operation and capital expenses for mobile operators. Also, that expectation and expected decrease of development costs, right, and improve time to market, all that reducing multiple vendor lock-ins on certain elements and systems in networks today. What can you test in an Open RAN environment? Well, to begin with, there is the virtualization of many existing and some new network components. You have to check on the new data aggregation points, the functional splits as well. There are new interfaces. We mentioned that the F1 before, right? These are also carrying now new transport protocols like eCPRI, which we will talk more in another slide. So there's a lot of things there that you can validate for an Open RAN environment. VIAVI, by the way, VIAVI Solutions is very active in Open RAN developments, in Open RAN standardizations, including interoperability testing. We are part of several working groups in the Open RAN Alliance, and we invite you to go to this link that you see in the slide. It's a virtual exhibition at openran.org, open interface, and you can choose a demonstration case there. Any of the demonstration cases available there to learn more about the specific Open RAN developments at different network stages. So it's actually highly recommendable. So regarding the type of tools that are being used in 5G network validation labs these days, you saw maybe some of the names indicated in previous slides, like TM500 or TeraVM. That's just a brief note on a couple of these leading solutions that they offer by VIAVI. The TM500, it's a very flexible, highly flexible test mobile system. It's very popular these days with base station vendors, manufacturers as well, but also helps mobile operators validate all these test scenarios that we described in the previous slides to assure the best possible 5G quality of experience in the users, right, in the final users. This system includes, for example, the ability to do a validation of multi-vendor interoperability and also 5G, 4G interworking validation. That's important because today when we talk about 5G, remember we're talking mostly about non-standalone 5G mode. So 5G relies on 4G in fact to work. But obviously there's the upcoming standalone mode that may require also interworking with different core types, and that will be a very interesting application as well. Deployment optimization and performance tuning is another area that the TM500 does very well, and this can help, in fact, operators differentiate over competition. And finally, we also mentioned about the need for automated regression tests, make sure that everything works fine when a new upgrade is coming, so before the upgrade is implemented in the production network. The other solution that you see here on the slide is called the TIRA-VM. And this was, by the way, the industry's first network function virtualization test solution for 5G in the market. It provides a very comprehensive validation of 5G and Open RAN technologies end-to-end. So this is not so much about testing against the base stations, but basically it's a more end-to-end approach through the network, right? And that's this based on application emulation. So before new services and new network functions go into production in the commercial network, you can actually validate all that with the TIRA-VM platform. And you can validate also functional system testing. So that's another advantage of the TIRA-VM. That what that means is that you can validate that any new adopted protocol or any new interface works against the standard specifications like 3GPP or Open RAN or any other that may become relevant in the future as well. So that's for the things that we have seen today in testing 5G network services in the lab with our customers. The next section here is going to briefly review main changes in the infrastructure for 5G networks. This is not intended as a comprehensive list of all the possible changes, but a quick description of the main things that are different or new in 5G when it comes to the access networks, transport, and radio. Everyone will agree these days that there is more fiber at 4G base stations, and even more fiber is expected for new 5G sites, right? And as we prepare for higher bandwidths and lower latencies, a new network architecture in 5G will draw new lines between the traditional front haul and back haul segments and bring more complex topologies. In this scenario, 5G will drive extreme fiber growth with multiple channels per fiber, since radios will have now 10 gigabits or even 25 gigabits from front haul interfaces, right? Not to mention future, but not so distant, 100 gigabit transport networks to support the 20 to 30 times more small cells in dense urban areas that everybody's talking about for 5G massive deployments. Overall, it's fair to say that 5G is driving upgrades across the fiber front haul and transport infrastructure worldwide, and the capacity of the wired network supporting 5G infrastructure is key. Even so, this also means that there will likely be more points of failure with higher split ratios between radio units and distributed units and more fiber legs to maintain. Regarding the specific fiber topologies that we are seeing at the beginning of this 5G early cycle, here at VIAVI, we have noticed dark fiber and WDM technologies have been initial choices. So this depends on different markets, obviously, it goes market by market. However, we also expect next generation PON and Ethernet-based TSN networks to play also a role in the future for transport networks in the field. At this time, we'd like to roll a quick poll with the audience to get your feedback on what are your expectations, what are your points of view regarding the fiber implementation for 5G networks. Ahmed, can you go ahead?
Yeah, it's done. Yeah, it's already there. So if you can please put your votes to the most possible answer that you have over there.
Ahmed, I assume the poll is green, by the way, it's been shared. That's not on my side, but I assume for the rest of the people.
It is. Yeah, it is. Yeah,
Okay.
it is.
Just checking.
And we're collecting the answers now. I'll close the poll in 10 seconds. We have almost 52 people, 52% of the people voted. And you would like the result. It's really, really nice. Okay, so I'm closing the poll now. So the answers came 37% to the dark fiber, 29% to the XWDM, and 23% PON, 12% for the others.
Wow, it's actually very, very well distributed.
Yeah, exactly.
So that means probably there is not a mainstream strategy, as we mentioned before. This goes market by market, depending on the circumstances of the fiber infrastructure being deployed in each particular country, right? But yeah, it makes sense that we see at least dark fiber and WDM at the top, but following very close by other networks technologies like, for example, PON. All right, so makes sense. No question. The next slide here, it's talking about transport in 5G, right? And this is also an area that will experience a major transformation compared to previous 4G architectures to hold up with the new 3GPP standards designed to support multiple use cases and verticals, particularly those related to very low latencies. The traditional backhaul front haul division here we had in 4G will open up to hybrid models, as you can see that in the slides. And that may include a new mid-haul segment that didn't exist before, and more complex architectures where elements like the distributed units and the centralized units can play alternative management roles. The SLAs, the service level agreements for the mid-haul, are expected to be very similar to backhaul and will require measuring things like bandwidth, delays, jitters, packet loss, right? So you have things like the RFCs 2544 and similar. The SLAs for the front haul, however, may become much more stringent, right? So measuring latency in the front haul to ensure that it's within budget is going to become critical. The same way that basically measuring timing and synchronization will become absolutely critical, especially for the eCPRI transport protocol. Of course, the area that we are seeing major changes so far in cellular networks with the arrival of 5G is the radio access and the air interface. With the introduction of many novelties, including higher frequency operation in the new millimeter wave ranges, spectrum flexibility with things like a multiple choice of subcarrier spacing, or the new dynamic spectrum sharing mode that now everybody's talking about. Not to mention the new active antenna function supporting beamforming and dual connectivities. A major consideration for RAN evolution in 5G is also the densification factor that will bring an even larger footprint of small cells deployed in dense urban areas. We discussed that before, where traffic demand is typically higher in these scenarios. The coverage supplied by these new small sites will now be defined by very narrow reference beams, and new signal propagation and interference issues have started appearing already that are not the same ones that we had seen in 4G. We'll look into this in more detail in the next section of this presentation today. But if I can make another comment here, something that we are also seeing today in the field regarding 5G air interface is the absolute need to measure timing and synchronization. Let me repeat that again, as mentioned also in the previous slide. This is the same problems that we see also mentioned for ECP transport protocol, but at the air interface, this is very important as well, because at the end of the day, 5G is a TDD type of signal, and a lot of the radio problems in the field today with 5G are originated from time and synchronization errors, believe it or not. That's definitely something that we can tell has been our experience with many customers so far. And when you factor all these changes in the infrastructure, obviously it's not necessarily a big surprise to get sometimes performance results that turn out very different from the original expectations, right? So here you have a picture of a 5G phone showing a speed test 1.2 gigabit per second. And I'm sure that you have seen a lot of those in social media like LinkedIn's and Facebook's, that everybody with a new 5G phone is showing those highest speeds. What we say in VIAVI is that more often than not, you don't see when that is not the case, right? Nobody posts the picture when that's not happening. But that's not happening very often, in fact, right? There's a lot of common issues observed in the field at the beginning of this 5G in trials, proof of concepts, obviously, but even in commercial launches. And we see things like why I'm not getting the high downlink throughput that I expected, or why my downlink and uplink throughputs are so unbalanced, or why the 5G phones are not attaching correctly to the 5G radios, or they are disconnecting from the radios all the time for some reason, right? It's a lot of things going on there in the field, and these are in fact the questions that you see now here in the points that you see here in the slide are in fact very common situations that we see with our customers during these early 5G trials, proof of concept, even with the first commercial launches. So to address items, right? The last part of in this part of the last part of the presentation, sorry, today we are going to talk about some recommendations, VIAVI recommendations for field testing procedures when it comes to new rollouts of 5G networks, and this can help basically to prevent many of the issues that we have previously mentioned. So these slides will cover several aspects of installation and verification of the new 5G sites, and with some references to the legacy 4G, right? We will briefly discuss here items like fiber and transport installation in 5G, the need for antenna alignment, and several radio-related topics that have proved they can be challenging items during these early stages of new 5G trials and commercial launches that we have seen in many markets already. More often than not, one thing that we see with fiber in cellular environments is that is given for granted. And an optical fiber is indeed a very reliable physical layer. However, it has been also our experience that the best performance out of fiber comes when you adopt best practices like those that have been adopted in the broadband industry before. And that includes the need, for example, to perform fiber inspections, regular fiber inspections, make sure that the fiber is clean before installing, and also during maintenance also. So that's definitely
It seems that Janice is having a connection error. So if you can hold on for a second, I'll try to reach him in a quick way just to check his connection. Thank you.
Hello, Janice, can you hear us?
I hear you very well. I was hearing you all the time. Can you hear me?
We can hear you
Yeah,
now.
now we can hear you. Now,
We
yeah.
did have
I'm
a
very sorry about that. I don't know what happened.
okay.
Yeah, I think we lost you from the previous slide,
Apologies.
from slide number 24. No
From
worries, sir. No worries.
from 24, right? So I'm very sorry. I was actually
Yes,
able to.
at the end of 24. Yeah.
So
Okay,
shall we
please
repeat
go on.
this
Thank you.
slide? All right. Apologies to the audience for this situation. So I was talking about the fact that well, one thing that we see with fiber, particularly when you come from the RF environment, is that so often fiber is given for granted. And the fact that optical fiber is indeed a very reliable physical layer. However, it has been our experience that the best performance out of fiber transmission comes with the proof best practices that we have seen adopted in the broadband industry for many years. And that, for example, includes things like the need to perform fiber inspections and make sure that the fiber is clean before installing, and also later during regular maintenances. Checking the optical power loss is also a very good thing to do these days, always to make sure that the radios receive the appropriate signal levels and avoid communication issues that we see sometimes that appear when optical power levels are not sufficient. Also, I mentioned before that today there is a choice of very cost-effective fiber inspection tools that quickly identify if the fiber tips are clean enough and also allow to validate optical power levels easily and efficiently. More important, for 5G, these simple tools also support higher density connectors and transceivers that we see today that they are being used for 5G, like for example, the MPOs, the multi-fiber push-ons connectors, that they can host 12, even 24 fibers in the same ribbon. And then moving to the next slide, also related to fiber, we mentioned that, we discussed that in the previous section. There are new topologies arriving to the cellular base stations, like WDM, for example, with more complex multiplexers that can provide indeed many more traffic channels and capacity, but so often require the technicians to sort out and connect the right wavelengths to the different radios. This is an issue that we are often seeing now in the field in some markets. As I mentioned before, the introduction of high density connectors like MPOs, QSFP modules, and so also adds another layer of complexity here for the installation of the transport and the testing of the transport layer. Field tools today that are able to combine fiber inspection with DWM channel checking or even OTDR testing when required, they are available, widely available. OTDR testing, in fact, in particular, is something that we expect to see more and more as 5G moves into the standalone mode and fiber links get extended to significant lengths. In the transport side, based on our current experience, we expect the need for synchronization and testing to increase, the front synchronization testing to increase, that we mentioned that as well, not only at radio level, since 5G is a TDD technology, and therefore more sensitive to frequency and time errors, but with the introduction of transport protocols like eCPRI, it will require to secure that it is working in optimal conditions regarding aspects as like bit error rates, jitters, one-way delays against the RUs and against the radio units and similar, right? This will include, by the way, the need to verify time protocols like PTP and proper GPS installation in many sites that require cabling integrity, global navigation satellite systems availability, and good level of received signal strength and the alike. So a lot of things going on the transport side for testing these days. Still in the physical layer, antenna alignment is growing also in importance during the installation of new cell sites, and it is something to verify later during regular maintenances as well, particularly in areas that where the sites are very exposed to certain climate conditions. Well, this is already a highly recommended validation activity for 4G with using passive antennas, and even for other communication systems like microwave links. Antenna alignment has been identified as very, very critical for 5G technology. The reason is because in 5G, the coverage comes defined in the form of very narrow reference beams, as we mentioned previously, that they are distributed typically in semicircle configurations, like is usually the case for deployments in Europe and the Middle East, in 3.5 gigahertz, where up to 8 reference beams are often transmitted from the same active antenna. You can imagine these new type of signals that are so narrow, any misalignment of the antenna in terms of azimuth, tilting or rolling, can produce a completely different coverage result than originally planned in the design stage. So even furthermore, when 5G operates in the so-called millimeter wave, like in 27 gigahertz or higher, it is possible for 5G antennas to transmit up to 64 reference beams in a horizontal and vertical 8x8 distribution. And here is where it takes even a more critical importance to secure an accurate azimuth and tilting position during the installation of these new antennas, and of course making sure that those azimuth and tilting values correspond to the original targets defined during the planning stage. There are very effective antenna alignment tools today in the market, and a few even include the ability to take a picture to confirm that the antenna is set according to the original target values, and allows for a very effective report, for example, of any possible line of sight obstructions, like new building constructions or growing trees or similar, that were not taken into account during the design and planning stages. As you know, when we talk about 5G today, we are referring to the 5GNR new radio standard, which by its own name indicates the main difference at this early stage of the technology cycle is the new radio interface, right? 5G signals introduce some novelties, like the fact that it's primarily a TDD type of signal made out of uplink and downlink time slots sharing the same frequency range or channel. Another new factor is the presence of a synchronization signal block, SSBs, that carries the reference beams or coverage beam that we discussed in the previous slide. One major source of problems that we have seen in the market are associated to the presence and location of the SSB within the 5G signal carrier, since this can be placed in different frequency locations. Other problems that we are seeing of late have to do with the increase of multiple 5G carriers in the same location, where these signals now sit one adjacent to the other, creating adjacent leakage interferences. So be aware of that new situation now in the field. Physical resource blocks distribution is another common topic that defines the actual quality of service in a 5G signal, because it basically tells you in terms of user throughput, for example, what is the quality of service that you're delivering in terms of user throughput. Last but not least, 5G is operating in new frequency ranges like millimeter wave in some markets, or the mid-band is more often here the case in Europe and Middle East. And that may require the traditional band clearing and interference analysis jobs to make sure that no other alien signals are messing with our brand new 5G service. In this regard, traditional sweep-tune spectrum analyzers have been the tool of choice many years for testing RF in the field, also in the cellular space. However, this type of instrument have proved less than ideal for the new 5G signals due to their TDD nature, as discussed, and the need to check additional aspects like the presence and location of the SSB block, not to mention other compliance tests like occupied channel powers, adjacent channel leakage ratios, and similar. A new generation of tools have come to our rescue, fortunately, in the form of portable, battery-operated real-time spectrum analysis that can display different power levels, different power values, in the same frequency point, discriminated by a color scheme. So these are called power persistence or persistence displays. The immediate benefit for the technician using this type of new generation tools is the ability to observe these TDD signals like actual whole carriers, almost like they were FDD if you want. And also these tools immediately identify any sort of spurious and other alien signals when the persistence of this is enough to interfere. One additional advantage is the ability to highlight automatically the presence and location of the SSB block in the 5G carrier, given that the SSB can be in fact the most persistent part of the 5G signal. Once the RF condition has been validated, we may want to check the performance of the 5G channels represented by the signal carriers that a mobile operator may be transmitting through a 5G channel number. This can be located in different frequencies and have also different bandwidths. So for example, channels located in the 3.5, 3.6, and 3.7 gigahertz and with up to 100 megahertz of analysis bandwidth are common, but in other regions, it could be, these carriers could be located in millimeter wave ranges, for example, in 27 gigahertz or even 39 gigahertz and have even different bandwidths. It could also be that these days that a mobile operator is transmitting more than one channel carrier in the same location. This is something that we're seeing now with some few customers. And this is something referred to as carrier aggregation. And you may want also to compare sometimes the performance of your channels against those of your competition in the same geographical area. Regardless of the test case, so channels are transmitting from each different radio through a PCI value that's unique to that radio sector. And it is important to validate that the PCI distributions in a given area correspond to the original plans. Correct signal propagation, path loss, ingression and egression from outdoor to indoor, or the other way around, are also important validations in the field. Test equipment like the new 5G field analyzers are able to support a number of performance indicators on 5G channels, including channel powers, EIRPs in some cases as well. Error vector magnitude is a good indicator of any issues impacting proper signal propagation. As of recent, we have in fact seen an increasing interest also on 5G synchronization measurements over the year with the most experienced customers that we deal with, because a lot of the 5G situations that they are experiencing, the problems that they are seeing, can be traced back to an excessive amount of frequency errors and also time errors. Again, these are important metrics due to the fact that 5G is a TDD, the TDD nature of the 5G signals, and this is something that many of us were not exposed to in 4G, right? Because LTE was mostly an FDD type of signal, not everywhere, but in the majority of the cases. Once a validation is conducted at carrier level, we can move to a different analysis at beam level. Remember, from each channel carrier, there will be a number of reference beams transmitted over the SSB block. That means each individual beam will have its own index value, whether that's 4, 8, or 64 beams are being transmitted at any time. These reference beams in 5G define the overall cell coverage, and it is critical to validate that they are all transmitting correctly, since anything wrong with one single of these beams could result in only partial coverage from that particular site or a very limited quality of service delivered by that radio sector. The same 5G field testers that we have discussed for real-time spectrum analysis or carrier checking can also perform beamforming analysis, providing indicators at individual beam level, including the RSRPs, RSRQs, CNRs, that we are already familiar with from the LTE reference signals in 4G. However, the difference here and the additional layer of complexity is that we are no longer dealing with a single reference signal per radio, but so often we deal with up to 8 different reference signals per radio, or even 64 beams, reference signals at one time if we operate 5G in millimeter wave. Finally, in this sequence of test validation in the field, coverage verification is a classic. It's a classic one, right? This is when we try to understand how well a radio sector provides reliable service to end users located in that area. This type of testing has been conducted typically with drive test tools and with other test sets like the same 5G file analysis that can also support channel scanning measurements that are time stamped and geolocated through GPS or other methods for indoor testing in shopping malls and similar when GPS is not always available. It has been our experience that coverage testing in 5G can be tricky, particularly for millimeter wave frequencies that are highly directional type of signals, when you need to use special types of omnidirectional antennas to receive signals from all the possible directions. But even in the mid-band, like in 3.5 gigahertz, there are several challenges there as well. One additional layer of complexity is testing coverage in 5G is often the need to compare the legacy 4G signals at the same time that could be basically with multiple carriers in the same location where the new 5G carrier operates, or even now with simultaneously multiple 5G carriers as well, right? This is the case because we operate in the so-called non-standalone mode that requires a 4G anchor signal to go along with the 5G ones. We also anticipate, we also have seen, as a matter of fact today, a lot of interesting challenges with the upcoming dynamic spectrum sharing mode. This is a technology that some of our customers have started testing with and allows deployment of both 4G and 5G channels in the same frequency band, in the same frequency channel. And that dynamically allocates spectrum resources between the two technologies based on user demand. Overall, validating the concept of coverage in 5G is expected to get more challenging, definitely, than we are used to with the existing 4G networks. This completes this section about testing procedures in the field, recommendations from VIAVI. At this time, we'd like to make maybe a second poll, second and last poll to the audience. Sure. Ahmed, back to you.
Yes, it's pushed now, so people can start putting down their answers, please. Yep, we're starting getting answers now. Leave it for a while. Another 10
Ahmed,
minutes, 10 seconds, sorry.
I was going to say, Ahmed, I assume the audio, the quality has been remain good, no more trouble?
Yeah, it's fine. Yeah, we've been hearing you. Yeah, it's fine.
I don't know what happened, okay, to be honest.
Yeah, it's communication network. Okay, so I'm closing the poll now. And the results are 46% goes to the lower throughputs than expected. 27% goes to the interference problems with 5G signals. 22% goes to 5G phones disconnecting from the 5G network. And the 5% for the new 5G phones not attaching.
Yeah, that's actually very consistent with our own experiences in the field, and definitely align with the points that we mentioned in a previous slide. So it's clear that that's main situations that everybody's experiencing these days. All right. So on a final note here, regarding all the different tests that we described in the previous slides, is that all of that may appear like a complex, cost-demanding activity, and if you need to test everything, fiber, transport ref, there is indeed an associated cost. No question there. But that has to be compared with the cost of testing too little or even not testing at all, and then risking to face network performance that could impact the capacity of the overall quality of service delivered, right? And to mitigate those costs, those associated costs, a new approach for network testing in the field is emerging based on the concept of workflow automation. This consists of making sure the process of testing and creating reports for site commissioning or other test cases like regular maintenance are fully integrated and automated in the testing tools themselves. This capability really facilitates all the testing. So, for example, the new generation tools can be operated by experienced users, obviously, but also by entry-level technicians. That's another consideration. If you're interested in more details about workflow automation for testing existing networks and, of course, the new 5G rollout, please reach to us, reach to VIAVI, where we will gladly explain this idea in more detail to you and how that can save you money in operational costs while improving your time to market and the overall quality of the network. At this point, I'm moving the control back to my colleague Ahmed Anan, who will give us a closure note for the session today.
Thank you, Janice. It was really beneficial, and I think we're getting very close to the close time, so I will not spend a lot of time on the slide here. It is, it is one of the best slides that we have in our company, and we're really addressing, what we see as the need for the market for the 5G. This is what we call the lab to field initiative in VIAVI, where we do have really solutions that can help you, help your partners, your integrators, your contractors to address the different challenges in the different parts, the lab, the field, and the assurance, where you can do the validation for the technology and the experience in the lab using the TM500 with the end user experience and the ONT 600 for the optical network testing and the other applications as well. Or you can go towards the field where you need to do the verification part. And the verification part raised there over there, if you can remember from the different use cases that Janice mentioned, which is related either to the RF validation or related to the fiber inspection and certification, or related to the eCPRI and the backhaul protocols, different aspects as well over there. And the last part, which is related more into the assurance or the visibility of the high level visibility of the operations, we do have the solutions that can aggregate the results not only from our testers or our data capturing points, but also from the other network element logs like the Nitro Mobile or the Nitro Geo. And of course, for the physical testing, which is getting more and more important, you need something that do 24/7 monitoring, which is our on-MSI fiber monitoring solution. So you will have these slide sets and you will have the recording, and I would appreciate if every one of you would really look into this slide and understand where does his needs come from and where is the potential requirements really, focusing in each one of these areas. And we're really helping you. We really can help you with any of these different areas. So Janice, if we can move to the next slide, please. That's, I think, the, yeah. Okay, so in this slide, this is something that's we're really encouraging you. We mentioned that at the beginning by Carol. I mentioned it and I'm mentioning it again. Please take that. You will really like these seminars. Most of the webinars that we have are more of technology addressing webinars. We're here to help with our experience from the field to you as our partners and customers with what we have. So you will have the slides. There is a link over there. This is what we call the Spring Summer Webinar Series. Please go to register over there. You will find a very long list of the webinars that you can attend. Choose the ones that you prefer or it's really matching your area and register to it. Okay, so I think we still have 1 minute, so maybe we can have one or two questions. Janice, are you ready for that?
Yeah, absolutely. If there are questions available, yeah, absolutely, by all means.
Okay, so the first question is asking, is it possible to simulate open distributed units for O-RAN testing?
Oh yeah, that's a good question, and the fact is yes. So basically, I mentioned that before at the beginning of the section during the lab validation part, right? That VIAVI has the ability to load traffic, emulation traffic for DUs to test the centralized units, and that's a fact also. That's true also for in open RAN environments. So basically, certain definitions of open distributed units, we can load traffic, emulation traffic for these open DUs, and to test the CUs across the F1 interface. It's one of the type of tests that now they're getting more popular in open RAN environments. Yeah, absolutely.
Okay. Another question which is related to the RF testing. Why the SSP not always in the middle of the 5G channel?
That's a very good one, and it's a major source of problems these days, right? So we mentioned before that so often the phones are not attaching to the network. And why is that happening? So this is because the phones do not know where the SSB is located, or the SSB is located in a position within the carrier that is not expected by the phone, so it cannot see the reference beams and therefore cannot attach to the network, right? So it definitely has been a major source of problems in initial trials, even in commercial launches where the phones could not see the SSB. So 3GPP have not make the position, the location of the SSB mandatory in the 5G carrier, and in fact gave a lot of flexibility in this regard. And one of the reasons has been to facilitate, for example, the combination of 4G and 5G signals in dynamic spectrum sharing mode, where the SSB of the 5G carrier can be located in different locations, can be located in different positions in the carrier, even at the edge side, for example, of the signal carrier. And this way does not interfere with the LTE reference signals when 4G and 5G signals are being transmitted in the same frequency channel at the same time because of this new dynamic spectrum sharing mode. There's other reasons to provide all this flexibility to the SSB location, but this has been one of the major drivers for 3GPP not to make mandatory any particular position of the SSB.
Okay, thank you. So there are a lot of other questions, almost another 5 or 6 questions. So I'm apologizing for the people who have raised the questions. You know, we're running out of time. So we will be addressing all the questions. Janice will send the answers to your email. We need to close the session now, so we conclude the day webinar, and I would like to thank you, Janice. I'd like to thank the attendees as well for your time. We really appreciate you being here. Again, as a reminder, this is part of the Command for the Command Network Spring Summer webinar series. So we really would like you guys to go and register into this link for the future webinars that will take place, or even watch the recordings for the previous webinars that we had. For the webinar that we've done today, you will receive the recording by email, and also you will receive a very useful handout that has been available in case you didn't download it, which is related more to the site testing and what are the procedures that we're recommending for the 5G site testing. Thank you again, Janice, and thank you all. Take care.
Thank you, everybody.
The webinar now. Thank you. Bye.